Hello and welcome to today's video lesson where we're going to talk about one of the most commonly misunderstood exponent properties, and that is the negative exponent property. So what does it mean? How does it work? The most common misconception is that if you see a negative exponent that your answer will be negative, and that's just not true. That's not how negative exponents work. What's the real deal? All expressions either are fractions or could be written as fractions like so. And what a negative exponent really means is that this factor, in this case x, it's not where it wants to be. X has a power of -2, which simply means it wants to go to the other side of the fraction. And so x to the power of -2 over 1, I'm going to flip that x to the power of -2 down to the denominator. Now it becomes x to the power of +2. Notice that there was a 1 there, and I don't have to write that anymore. It's like 1 times x squared, and you never have to say 1 times anything. And, well, what do I put in its place? Well, again, if I'm moving something from one side to the other, and now there's nothing there, it's not actually nothing, it's not 0, because just like this is secretly 1 times, so is this 1 times x to the power of -2, right? And so that 1 is still remaining there. And I bring that up because another really common misconception is that, oh, it means to switch just flip that fraction over. And in this case, it does look like that's what happened, but that's not really what's going on. That's not why the ones appeared to trade places, right? It's that both sides had a 1 and both sides still have a 1. It's just that we don't write it if there's something else there. And let's show what I mean by that with this second example here. A really, really common mistake and misunderstanding is that students will just turn the whole thing over and say, yeah, I did it. I got rid of that negative exponent by flipping this fraction over, but that's just not how it works. That's not what the negative exponent means. It just means that one factor, just x, is not where it wants to be. 2 and y, those both have their own exponent. Every factor in a problem has its own exponent. So 2 has a power of 1 because if you can't see a power, it's 1. Same with y. They have their own exponents. Leave them where they are. They're happy there. In fact, one of the corny things that I like to say is that, sorry about that. One of the corny things that I like to say is that if it's got a positive exponent, it's positive. It's happy there. Leave him where he is. He's happy. He's positive. It's only this one with the negative exponent. He's not happy. He's negative, right? So 2 is positive. He's happy. Leave him. He's on the numerator. Leave him on the numerator. Same with y. Y is happy. Leave it there. So 2 and y stay where they are. The only thing that moves is this x to the power of -2 because it has a power that is negative. We're going to flip it down to the denominator and say that now it's got a positive exponent. Let me write that a little bit bigger. There we go. And this is really how to simplify that. Only the factor with the negative exponent is the one that actually moves. So the final real misconception that comes up a lot with the negative exponent property is that students think that a negative exponent means that it always goes on the denominator. Even these first two examples, the thing that had the negative exponent ended up on the denominator both times. But that is coincidental. That is not, again, that's not what the negative exponent property says. It does not say to put it onto the denominator. It says to put it on the other side of the fraction from where it already is. So we can see that our factor b here has a negative exponent, but it's already on the denominator. We're going to end up flipping it to the numerator. But first, let's talk about the other stuff in this problem. For instance, this is the only problem so far where we have a coefficient here that can be simplified. We have 3 and 6, so just like other problems, we can totally, separate things, deal with them one at a time. And of course, 3 and 6 are both divisible by 3, and so we can call this 1/2. Let's toss that into our answer so far. Moving on, we see a's, and that's, again, this time we can do something with that. We have a's on the numerator and the denominator, and of course I can rewrite it like this. I have 4 so-called multiplying a's and 1 dividing a. And if you don't know what I'm talking about with that, go watch my video on the quotient of powers property. So I have let me try that again. I have 4 multiplying factors and 1 dividing factor, so I can cancel 1 multiplying and 1 dividing factor. I end up with 3 A's that are on the numerator, so I can toss that into my answer. And then comes the B's. So here's, again, what I see a lot of students do. They write it like this, and they say, oh, b to the power of -3. Based on that other example, especially like this one here, I can just toss it down to the numerator, and it becomes 1 over b to the power of 3. All right, done. Except that that's not how it works. That is not what a negative exponent says. It does not say that it's going to end up on the denominator, and the mistake here was not realizing that b to the power of -3 here, it was already located on the denominator. So the work should not start like that. Really, the work should start like this. This is what's really going on here. This is a negative exponent that's on the denominator to start with, and in order to make the change here, we're going to put it onto the side that it wants to be, onto the other side of the fraction. This is what we should say. And once again, we can toss that into our answer, and that's all of the pieces. We have our coefficients, we have our A's, we have our B's, all of them taken care of, all of them with their partial answers. And now we can multiply everything out. 1 times a cubed times b cubed is a cubed b cubed. 2 times 1 is 2, and this is our answer. It's not the only way to write this answer, by the way. Dividing by 2 is the same as multiplying by 1/2. So if you prefer, you could write it as 1/2 a cubed b cubed, and these are both perfectly valid. Which one I prefer? I don't know that I really have a preference. They're both good, so check, check. They're both great. All right, so that's what a negative exponent means. Those are the 3 main mistakes that I see from Algebra 1 students. And let's put it all together in one more, kind of complicated example. Here we are with our final example, and we can see now we're going to have to use this negative exponent kind of in conjunction. We're going to have to chain it together with other exponent properties. In this case, we're going to have to use the power of powers property, and we're going to have to use the power of products property. So the power of products is the one that's kind of like the distributive property. Don't actually call it the distributive property. You're going to get laughed at, and then in turn, I will get laughed at because I'm the one that's teaching it to you. So don't call it that. But we're going to distribute this power of -2 to everything inside of the parentheses here. And that goes for both the numerator and the denominator. And, great, we can rewrite this. And we also have to take that, like I said, power of powers property into account. Sure, we give everything inside the parentheses that outside power, that power of -2, but if it already had an exponent, that's when we multiply the exponents together. 3 times -2 is how I got -6. Same with 2 times -2 is how I got -4. And now we can use our negative exponent property to help us out. And so again, the negative exponent property does not say switch everything. It does not say that everything should end up on the denominator. That's just not what it says. It says that everything with a negative exponent wants to go to the other side of the fraction. So if any of these were a positive exponent, for instance, if this was x to the power of +6, then I would be leaving that where it is. So the only reason that everything's going to end up switching places on this particular problem is because everything has a negative exponent. So only the ones with the negative exponent want to change, but that's everything in this problem. So we're going to rewrite this, go one factor at a time. 4 to the power of -2 is on the numerator, and we're going to switch it down to the denominator because that's how we get rid of that negative exponent and change it into a positive one. X to the power of -6 becomes x to the power of +6 on the opposite side of the fraction. Same with y. And you know what? We're going to do exactly the same thing with the denominator. 6 to the power of -2 becomes 6 to the power of +2 on the opposite side, which is in this case now the numerator. we're going to do the same thing with the variables. I'm going to go ahead and rewrite this one more time because 6 squared and 4 squared, there's nothing wrong with writing it that way, but if you're going to simplify something, then you should do those calculations when you can on the numbers that you can do them on. And now that we've gotten this far, we can, just like we did before, grab one piece at a time. I'm going to take the coefficients, 36 over 16, and simplify those. Again, the goal of this particular video is not to work on simplifying fractions, but one thing that I do see a lot, even still, is that students get frustrated with fractions a lot. And so one really common thing I see is not knowing the best number to divide by, and I just want to remind you that that's okay. If you don't know that both of these are divisible by 4 just by looking at them, it's not that big a deal. We do know that they are divisible by something because they're both even numbers. And so I'm going to divide them both by 2 and get 18 over 8. And if you do that and you say, all right, I'm done, then you didn't look closely enough because those are both numbers. Both of those numbers are still even. So I could do that again. And so there's nothing wrong with doing something in multiple steps. Yes, I could have divided by 4 to begin with. Is it that big a deal? Not really. It's just one more step. Whatever. So let's go ahead and toss that into my working answer, or my answer thus far, and move on to the x's. So I have 2 x's on the numerator and 6 on the denominator. And just like in the previous problems, if I have a multiplying x and a dividing x, I can cancel them out. Same deal one more time. I end up with 4 x's remaining on the denominator. Now for the y's, I start with 4 y's on the numerator. And just like with the x's, I can cancel out 2 of them. 2 multiplying and 2 dividing factors, and I end up with 2 remaining on the numerator. So once I've taken each piece, each sub-answer, I can put it all together. 9 times 1 times y squared is going to be 9y squared. 4 times 1 times x to the 4th is going to be 4x to the 4th. And you know what? That's going to be my answer. So is this a bit of a complicated process? Sure, it took me how many? 1, 2, 3, 4, 5, 6, 7, maybe 8 steps, depending on how you see it. And that takes a while. But even these complicated processes, if you do them one step at a time, utilize one rule at a time, they can be done, they can be broken down, and they can be solved. So keep that in mind, don't give up on them, and hopefully now the negative exponent property makes a bit more sense. And that's it for this video lesson. So thank you for watching. I hope it was helpful, and I will see you again next time. Bye-bye.